All right, so last time we did tutorial sheet 3. So today we are starting tutorial sheet 4. So we hope to finish this tutorial sheet so that hopefully a number of us will be ready or will be half ready for the test. And most likely we can, before Thursday, people can ask me questions on tutorial sheet 5, and I'll be able to respond to them. Most of you haven't been able to respond to you because we didn't reach tutorial sheet 4, so it will be unwise of me to start answering questions because it will discourage people from attending the tutorial. All right, so we go on tutorial sheet 4. It's about logarithm. So we'll see how best we can work with logarithms. So the first question, somehow straightforward. Write each equation in its exponential form. So write each equation in each exponential form. So if you check there on top, I've given more like a hint on my solutions to say writing that equation in exponential form where you have y is equal to log b to the x, it is the same as b or y is equal to x. So if the argument is x, you bring it the other side, and then what was the other side, what was the answer becomes the power, and you maintain the base. So it's log to the base bx equal to y. So we change y becomes the power, we maintain the base which is b, and then we get the x, which was the argument, and it becomes your final answer. All right, so the first question, question A, has 1 is equal to log 10. So if they give you that 1 is equal to log 10, can someone kindly confirm you guys are able to hear me? Mr. James Zulu, sir, can you confirm you're able to hear me?
Yes, I can hear you.
Oh, all right. I'm sure most of you can hear me. All right. So 1 is equal to log 10. So if they just write it that 1 is equal to log 10, this simply indicates that this log has the base 10. So it has a base 10 somewhere here, which we are not seeing. So we don't usually put it there. We don't usually put it there, but it has a base 10. So according to this formula that we just showed up here, according to that formula, let me just highlight something in that formula. So the formula that I'm talking about is this formula. This formula. Right. So according to that formula that I've highlighted, it is telling us that if we have y is equal to log to the base b, then we have x there. Then it comes out as b to the power y is equal to x. So in this case, I've said if they haven't written the base, it means the base here is 10. It has a base 10, like that. So if it has a base 10, then our y is 1, our b is 10, and our x is 10. So what we did to this is what we're going to do to this. So we're going to say 10, which is our b, will be raised to the power 1, which is our y, and then we say it is equal to 10. You get the point? So that is how to go about that. That is the way to go with those equations. Okay, so let me just hold on a minute. All right, so let's continue, guys. So saying 1 is equal to log 10, so it will be 10 to the 1 is equal to 10. Then you've written it in exponential form. That is just how we write it in exponential. All right, sorry, I'm having some disturbance, but we can continue. So say 4, the B part is saying 4 is equal to log 10,000. So just like I mentioned, if it doesn't have a base, then automatically the base is 10. So it has a base 10. So 10 to the, so your base is 10, which is our B. So it would be 10 to the 4, which is, the 4 is more like the Y that we had there. So it would be equal to 10,000, which was the argument, the X. So it would be 10 to the 4, which is equal to 10,000. And you agree with me that if you raise 10 to the power 4, it would be equal to 10,000. Okay, is there any question before we move on? Can't get you, can you just repeat that?
Saying kind of
You're not clear, sir. Your network is bad. If someone is able to get him, kindly tell me what he's saying.
I think he said that repeat again.
Okay, so what I was saying is, if you have this, 1 is equal to log 10. So I initially gave you that y is equal to log b to the x. So this can be written in exponential form as b power y is equal to x. So similarly, we have this equation. So this equation doesn't have the base, if you've noticed, it doesn't have the b, the base. So in this case, since this doesn't have the base, then the base is 10. So kindly tell those who are texting me, class reps, tell those who are texting me that they are having a class, that I'm going to record this and they can watch it on YouTube later.
Excuse me, sir, before we can.
Yes, sir, go ahead.
Can I just say something before we can move on?
Sure.
Hello?
Mumba, go ahead.
Yes, I'm receiving some messages from some people saying that, yes, I'm speaking, sir. I think the network is just tripping. I'm saying that I'm receiving some messages from some people saying that the meeting is for authorized attendees only.
Okay.
So I don't know
what they are
has
supposed to do
do
is
with
to sign
settings
in.
or something.
They're supposed to sign in,
Okay.
maybe their Google account or their Facebook account. Tell them to do that.
Okay.
All right, let's continue. So, as I was saying, 1 is equal to log 10. So it means there's a base 10. So there's a base 10, which is not indicated. So it will be 1 is equal to log base 10, 10. So our base 10 is our B, and our 10, this 10 that is here, is our x, and then y is equal to 1. It will be 10 to the power 1 is equal to 10, of which you can agree with me that 10 to the power 1 is equal to 1. Yes, Dominic Chimba, go ahead.
Sir, sorry. Which tutorial is this?
Story sheet 4.
Okay, is all right, thank you.
Mute your mic. All right, so let's continue. We have that 1 over 3 is equal to ln of x squared plus 1 over x squared. So 1 over 3 is equal to ln of x squared plus 1 over x squared. So we know that ln is actually natural log of e. So ln, when you have ln, let's say ln of x, this is the same as the natural log, of e x. So this is what it simply means. So ln of x is equal to natural log e of x. So in this case, we have ln of x to the power 2 plus 1 over x squared. So we consider this as maybe our x or our y. So what would be the natural log? It will just be natural log e of whatever is in here. Then at this point, we can use the definition that we started with of changing exponential from logarithmic. So log base e of x squared plus 1 x squared, which is equal to 1 over 3, can be changed to say, okay, the base is e, you maintain the base e, and what was the solution, the 1 over 3, becomes your power, and what was your argument becomes your solution. So this changes to e to the power 1 over 3 is equal to x squared plus 1 over x squared. And since they're just asking us to change to exponential, we just end it there. So we end it there. All right, so we are done with question 1, unless you guys have a question. So if you have any question, feel free to interrupt, come in and ask me anything. All right, let's proceed. Since people have understood, there's no question.
Sir,
Yes, go ahead.
the one for question 3, it's the same procedure that we're supposed to do, right?
Pardon, can you just repeat what you said?
Question C, the one on question 1C, it's the same procedure that we're supposed to do.
Yes, it's the same procedure. So I'm leaving out C as your exercise. You can try that at your free time. All right, so let's proceed to question 2. Question 2 is telling us write in logarithmic form. So it's just the reverse of what we're from doing. So at this point, we're going to write in logarithmic form, from exponential form to logarithmic form. So initially, we were moving from logarithmic form to exponential form, but this time we're moving from exponential form to logarithmic form. So it's just a reverse, just like I've indicated. Let's start b power y is equal to x. Then this is the same as y is equal to log b to the argument x. So we have a question. e to the power 2 is equal to x plus 5. So what is this? This is the same as maintain the base, introduce a log, maintain the base, change, make this the argument, then make the 2 the solution. So it will be 2 is equal to log of e x plus 5. But log to the base e, what is this? This is the natural log of e, which is ln. So we introduce ln there and say 2 is equal to ln x plus 5. Alternatively, this question can be solved in this form. So we can introduce ln on both sides. So if you introduce ln here and introduce ln there, so put this in brackets. So you'll notice that this ln that is there, let me change the color. So this ln will cancel with the e. And then you remain with this ln. And then here you will remain with a 2, which is this 2 here. And it will be equal to ln of x plus 5. So whichever is okay with you, you can introduce it. You can either introduce log or you can introduce ln. And you still come out with a very good answer, which is correct at the end of the day. So that's the way to go with those types of questions. Then we have 5 to the 3 is equal to 125.
So what term are we? What term is it?
What time is the what? Okay, we proceed. 5 to the 3 is equal to 125. So we maintain the base as we introduce the log. The power becomes your solution. Your solution becomes your argument. So it will be 3, which is the solution, is equal to log of base 5 to the 125. So you've maintained the base, which is 5, and then you've made this solution to be your argument, and then your power has become your solution. So I hope we can see that. All right.
So
Yes, sir.
yeah, so about is it necessary suppose that
I can't get you. Your network is bad. Maybe write me a message on the chats there. Go on the chats. Write me a message. I'll read it.
So there is a lecture for SSS at 18 hours. So I'm asking what time is this tutorial ending?
The tutorial is ending at 19 hours. Don't worry, you can break through or remain with whoever will remain. Then I'll record the video and send it on YouTube. You can find it on YouTube.
Okay. All right.
So we have C. Okay, since people don't have these tutorial sheets, let me forward it in the group. Let me quickly forward it in the group. And please, I keep mentioning, guys, if you want to communicate to me when I'm conducting a tutorial, make sure you just send me a text message or a WhatsApp message. I'll be able to see it. Don't call me. Don't WhatsApp call me. You're disturbing my network. So the network is already congested. So the moment you start calling me, then it gets starts tripping. So you affect your friends. Okay, let me just share the video, then I'll be able to continue with this tutorial. Let me just share the tutorial sheet.
Those asking for the
The network is bad, just write me a message. Just write me a message, and just here on Zoom, I'll be able to read your message. Okay, so let's continue.
Sir, check.
I've sent the third sheet. It's not always necessary, but it looks neat to convert log E to lin for how much. Patrick, mute your mic. Okay. Let's move on. We are with C, b to the power x is equal to y. So we just switch them. It will be x is equal to log b y. So x is equal to log b y. And that's it. We are done with question 2. Let's move on to question 3. Unless someone has a question for me. Otherwise, let's move on to question 3. Question 3, evaluate. So we want to evaluate log. So if we are not given the base again, the base is 10. So it's log the fifth root of 9. So log the fifth root of 9. So you notice that 9 can actually be written as 3 to the power 2. And the fifth root of anything can be written as that number to the power 1 over 5. So in this case, we're going to reduce 9 to 3 to the power 2, which is the same. And then the fifth root of 3 to the power 2 is the same as 3 to the power 2 in brackets, raised to the power 1 over 5. Then if we expand at this point, we'll have 2 times 1 over 5. So it will be log 3 2 over 5. So without a calculator, the only point you can go to maybe is to just add this part, which says, you can just say, this is the same as, you can drop this power behind the log and say 2 over 3 log 3, like that. So you can have it like that. You have 2 over 3 log 3. So it's the same as log 3 to the power, sorry, actually that is not supposed to be 2 over 3. That is 2 over 5. So it's not supposed to be 2 over 3, but 2 over 5. 2 over 5, because it's raised to the power 2 over 5. Okay. So that is the way to go about it. Otherwise, if you want, you can leave it here. You still earn 4 marks. All right. Let's go to question 3C. 2 log 7 and the 7th root of 343. So we realize that 343 can be written as 7 to the power 3. And then what we have? We have the 2 log 7, then the 7th root can be written as 1 over 7 times the power of 3, which becomes 7 to the power 3 over 7. So at this point, you can either say log 7 is actually 1. 1 times 3 over 7 is 3 over 7. So it will be like 2 times 3 over 7, which is equal to 6 over 7. Or you can say you drop this power from here, you drop it behind the log, and you will say 3 over 7 times 2, which will be 6 over 7, log 7. But log 7 is 1. So 6 over 7 times 1 is still 6 over 7. So you will still come back to the answer 6 over 7. If you have any question, you can ask. Francis, go ahead.
Sir, on 2 log 77, what if it was a different number? Could it be the same as 1? For example, it was log 7 to 10, log 7 10.
No, log 710 wouldn't have been 1 because the idea of finding logs is like log of 7. How many times do you multiply 7 to get 7?
It's 1.
You get the thing. So you can't say
Yes.
you can multiply 7 one time to get 10 if there was 10 here somewhere.
All right.
Yes.
Thank you.
All right, we proceed. The D part, the D part, there's an error. I will send the correct answer. There's an error. So we skip the D. We go to question 4. All right, so question 4. Yes, sir.
So repeat on B.
I can get you.
I'm saying kindly repeat for the last time.
The C part. Okay, the C part says 2 log 7, the 7th root of 344. I mean 343. So if you check that, 343 can also be written as 7 to the power 3. Try that at your free time. So the 7th root of 7 to the power 3. This is the same as this. Okay, that one is making noise. Mute your mic. Mute your mic. All right, so this, I'm just getting this part. Just this part, huh? Because I think that's where people are confused. So this can be written as 7 to the power 3 in brackets like that, to the power 1 over 7. Get it? Margaret, mute your mic. We don't want to hear your conversation. All right. So
Margaret, mute your mic.
all right.
Sir, you can mute the mic, sir. You're the host.
Yes, I've muted everyone. All right, so we have that the 7th root of 7 to the power 3 is the same as 7 to the power 3 to the power 1 over 7. But then this 1 over 7, if we multiply it with 3, what are we going to get? We're going to get 7 to the power 3 times 1 over 7 is just 3 on top. And we say 3 over 7. So we are going to get that. And that is equal to what is here. What is here. So this is actually this. So that's where we got that point. I hope it's now clear to everyone. Okay, so let's move on. I'm sure it's now clear. So you drop this 3 power 7 here, or you straight away say log 7 is 1. So you remain with 3 over 7. Then 3 over 7 times 2, it will be 6 over 7. Then it's evaluated. Let's move to question 4. So if you check in your tutorial sheet, question 4 is saying expand the given logarithmic expression, assume all variable expressions represent positive real numbers. When possible, evaluate logarithmic expressions. Do not use a calculator. So we are not going to use a calculator because in this course, we actually don't use a calculator. So in this case, to expand that given logarithmic expression and possibly evaluate it, the first thing that we are going to do for question 4a, for question 4b there, it is log 4, the cube root of z over 16 y to the power 3. So you realize that when you are dividing these guys, when you divide these guys, it simply means subtraction of logs of the same bases. So we're going to do a reversal of when you are subtracting logs of the same bases, you divide the arguments. And when you're adding logs with the same bases, you multiply the arguments. So you have this dividing this. So in this case, we are subtracting. So you would say log base 4, the cube root of z minus log base 4, 16y to the 3. Then you also realize 16y to the 3 is an addition of logs because there is 16 and y to the 3, which are multiplying. So we can rightly say log 4 z, because the z, the cube root of z is the same as z to the power 1 over 3, minus log 4 16 plus log 4 y to the 3. Because we've just changed this guy and separated them because they're two multiplying numbers. So we'd say log 4 16 plus log 4 y to the 3.
Sir, before you go further, can you kindly explain again on how this one became negative log 416y3?
Okay, this is the concept that I'm from mentioning. I was saying if you have, let's say log a, log base a, x minus log base a y. So this is the same as log base a. You maintain the base, but then you divide your arguments. You get that? So if you say this, what we have here is actually what we have here is actually what is our final answer if we do subtraction of logs with the same base. So we want to reverse this to this. So we realize that since these guys are dividing, then we are supposed to subtract them. So that's where I got the negative log 416y to the base, log 416y to the 3. I hope that is clear. So after you get that, you separate them. So you see that these guys are multiplying, which shows it's plus. So we add here. We say log 416 plus log 4y to the 3. So you realize that this is the same as you drop this power that is on log 4 z to 1 over 3. You drop the 1 over 3 and say 1 over 3 log 4 z minus log 4 to the 4 squared, because 16 is the same as 4 times 4, which is 4 squared, plus log 4 y to the 3. So at this point, you have log 4 to the z over 3 minus 2 log 4, 4, plus you drop the 3 that was with the y to the 3 and say 3 log 4 y. So at this point, you come to log 4z over 3 minus log 4 is 1. 1 times 2 is 2, so it will be minus 2 plus 3 log 4y. I hope we get the point there. Then at that point, you can't simplify it further, or you can't expand it further. That's the expansion, the final expansion that you have. All right, so let's move on. Okay, so that was about question 4. That is how you go about question 4. So we go to question 4C. Yes, sir.
Sir, can you just
Sir, the question go up.
yeah, so it's
Sir, from the third step, how you move from the third step, if you can repeat again.
Okay, this is how we're going about it. We said log 4 the cube root of z minus log 4 16y to the 3. Then this 16y to the 3 is the same as 16 times y to the power 3. So times means we are adding logs of the same base. So that's why we came to this and said log 4 z, but the cube root of z is the same as z to the power 1 over 3. So we said log 4 z to the power 1 over 3 minus log 4 16 plus log 4 y to the 3. Then this is equal to, you drop this 1 over 3 behind your log and say 1 over 3 log 4 z minus log 4 16 is the same as 4 to the power 2 plus log 4 y to the 3. Then you drop the 2 and you drop the 3. So that you're going to have log 4z over 3 minus 2 log 4 to the log 4 plus 3 log 4y. Then you know that log 4 is 1. So it's going to come out at log 4z over 3 minus 2 plus 3 log 4y. I hope that is now clear. So in expansion, the person who is asking, what if we skip a step? We shouldn't be skipping any steps.
that was in my that was in
I was following
question.
2 questions. There are 2 people asking me questions.
My question was
what was your question? Go on.
No, it's been answered.
Oh, okay. All right. Let's move on.
No, it's been answered. My question was the same question. What if you skip that step while there's log 4?
You don't skip any step when expanding, you lose marks. So let's proceed. I've deliberately put this.
My question was the same question. What if you skip that step while there's log 4 squared? What if you just
product of roots?
go
So what is the formula of product of roots? So if you have the mth root of a root inside, the mth root of nth root of a, this is the same as you multiply the 2 roots and get mnth root of a, because we want to combine what is about to be solved. So in the equation we're about to solve, we realize that there is log the root of x, root of z. So, but the root of x can also be written, as the root of x squared, because the root of x squared is just x. So we introduce root of x squared and root of z, so that if we multiply the 2, we're going to have the root of x squared z. So that we can now have product of roots and handle that. So the root of x plus z, I mean the root of x root of z is equal to log root of x squared root z. And root of x squared times root z is the same as root of x squared z. So the root of x squared times z means we multiply the two roots, and what do we get? The fourth root of x squared z. So we get the fourth root of x squared z. So the fourth root of x squared z is the same as log of x squared z to the power 1 over 4. Then we can drop this 1 over 4 behind the log and say 1 over 4 log x squared z. But x squared z means x squared is multiplying z. So that is addition. So it will now be 1 over 4 log x squared plus log z in brackets. So meaning the 1 over 4 is multiplying both log x squared and log z. So at this point, we now have 1 over 4. If we expand this, we're going to have 1 over 4 log x squared plus 1 over 4 log z. And then, because the x is squared, we can drop the square that is with x to this guy. And when we multiply it, we're going to have half. So it will be half log x plus 1 over 4 log z.
Sir,
Yes, sir.
what if you went on to simplify, you write as the log x over 2 plus log z over 4.
Log x over 2 plus log 5. Can you just repeat your question?
I'm saying, what if you simplify it further by writing the final answer as log x over 2 plus log z over 4.
It's the same thing with this, sir. It's the same thing. Whether you end here or you expand, it's the same thing.
Okay.
I've seen a question from Melek Chambwe. Why are we squaring the x? So, Mr. Chambwe, sir, you realize that, I don't know if it's Shalambwe or Chambwe, Melek. So, you realize, Mr. Melek, that the square root of x squared is just x. So the square root of x squared is just x. Salome, write me a message, send a message on chat, send a message, I'll be able to see it. So the root of x squared is just x, sir. So when we introduce the root of x, it will be different from x. So that's why we squared the x, so that when you introduce the square root, it will still be the same. It won't change our question. I hope that is clear. Okay, let's move on. We go to D. On D, we have ln of x squared root of z over y to the power -3. Okay, I've seen a message that you don't understand. You can rewatch this video on YouTube. You can rewatch it several times. I'm sure you will be able to understand, because I will still repeat the same thing, which you can still watch on YouTube. Ln of x squared root z over y to the power -3. So this is the same as, because we are dividing there. So this is the same as ln of x squared root of z minus ln of y to the power -3. So that can further be simplified. We know that x squared is multiplying root of z. So that symbol gives us addition. So that gives us addition. So that tells us that that is now ln x squared plus ln z, but z, the root of z is the same as z to the power half. So that is ln x squared. So that is the ln x squared plus ln z to the power half minus ln y to the -3. So this -3 can be dropped. So the negative and the negative will become positive, and the 2 here can be dropped and the half here can be dropped. So we'll have 2 ln x plus half ln z plus 3 ln y. So 2 ln x plus half ln z plus 3 ln y. So that would be our final answer. All right, so I've noticed, guys, most of you are not understanding because you have missed the concept of logarithmic and exponential functions. So start by learning the basics of exponents, then learn logarithmic functions. So after learning those two, you'll be able to understand what we're doing. Francis, write me a message. So before you go and watch this, rewatch this video on YouTube, make sure you go and learn these basic principles of logarithm and exponential function. So go and learn the basics before coming to rewatch this video. All right, so let's move on. Move to question 5. I'm still waiting for text messages. Those who wish to ask me anything, you can send me text messages.
I have a question, sir.
Send me a message on chat because I've noticed your networks are bad. If you can't send your message,
Mine is just okay.
Oh, okay, James, go on.
Okay, so may you please scroll up a little bit?
Up to where, sir?
Yes,
Francis.
that's the answer for D.
The answer for what?
The answer for D.
The answer for B.
For D, question D.
Or for question D. Okay, and then?
D, question D.
I'm on D.
Yes, sir. Yes, sir. Here on where it says 2. Yes, on D. 2 ln x plus 1 over 2 ln z. Here on 1 over 2, why isn't it, why don't you finish it to say ln z over 2?
It's the same thing, sir. It's just the same thing.
It's the same thing?
Yes, it's the same thing.
All right, I just wanted to find out if it's okay.
Sir. Sir.
Let's go on and that.
Hello. For me, my concern is on why are we multiplying the negative, or what if we write 1 over 3 in y 1 over 3 for you to get rid of the negative there?
Don't get rid of the negative power by saying that. Instead, it is supposed to show 1 over y to the power 3, not y to the power 1 over 3. No, that is not correct.
Okay, so now on the same answer, why is it like, oh, okay, yeah, sorry, I've seen it.
Okay, thank you.
Oh, okay, yeah, sorry, I've seen it.
So let's proceed. Let's proceed. Question 5. So we go to our tutorial sheet. What is question 5 asking us to find? Question 5 is asking us to find, write each expression as a single logarithm with a coefficient of 1. Assume all variable expressions represent positive real numbers. So how do we do that? We go to our solutions. We have the first part, log of x plus 5 plus 2 log of x. So what do we do? Log of x plus 5 plus 2 log of x. So this is the same as log of x plus 5 plus that 2 can be brought in and say x to the power 2. So the 2 can be taken as the power. So we do the reverse of what we are from doing, where we were dropping the powers. So we take back the power because we want the coefficient of a log to be 1. So we take back the power and say x power 2. So it will be log x plus 5 plus log x squared. So this will now be equal to, because we are adding. So what does addition mean? Addition of logs with the same base, we multiply the arguments. So we have log x plus 5 times x squared. So if we expand, we'll have log of x to the power 3 plus 5x squared. I think this is straightforward. I don't think people would have questions on this. Okay, let's proceed and see what we have. Question 5b, we have log b x squared plus 7x plus 12 minus 2 log b x plus 4. So we have log b x squared plus 7x plus 12 plus, we raise that to, it will be a power of x plus 4, so it will be log b x squared plus 7x plus 12 plus log b x plus 4 to the power -2 rather. So it will now be, since we are now, we raised a negative power. So since we raised to a negative power, so this changed to positive. So the change to positive, what does that give us? That tells us that this will now be a multiplication of these two. So it will be log b, open brackets, x squared plus 7x plus 12 times x plus 4 to the power -2, which is the same as, to the power -2 is the same as 1 over x plus 4 to the power 2. So now at that point, we can simplify x squared plus 7x plus 12 because we can factorize this. So the product is 12, the sum is 7, two numbers that we can multiply to get 12 and add to get 7, that is 3 and 4. So if we simplify, we're going to have x plus 4 and x plus 3. So x plus 4 and x plus 3 is multiplying 1 over x plus 4 squared. So the x plus 4 can cancel one of the x plus 4 on the x plus 4 squared, and we remain with x plus 3 times 1 over x plus 4. So this will now be log of b x plus 3 times 1 over x plus 4, which is the same as log of b x plus 3 over x plus 4. That is equally straightforward. If somebody doesn't know that, I guess they don't belong at uni. They need to go back. All right, so
Science.
Excellent.
I'm just what?
You're moving too fast.
You can rewatch the video, sir, at your free time. You can repeat it over and over. So I'll just repeat at this part. So if you want here, if you want at this part, you can just raise to the power +2 and remain with a negative here. So if you remain with a negative, what is it going to give you? You're going to know that it's division. So instead of, if this is raised to the power positive, then this is negative, then automatically at this point you divide. Then proceed, you still come up with the same solution. We go to C. C says ln open brackets y to the power half z minus ln z to the half. So this simply tells us that we are dividing because we have same base ln and ln, but then we have a minus here. So we divide y to the power half z over z to the power half. So division means we subtract the powers. So z is power 1, so it will be 1 minus half for the z that is down. So it will be z power half. So we'll have ln of y to the half, z to the half. So ln of y to the half, z to the half. So after we get that at that point, we can simply get the half outside. So we can put the half outside the box and say ln of yz, open in brackets, to the power half. So I'll repeat, ln y to the power half z minus ln z to the power half. So this is the same as ln y to the power half z over z to the half. So z divided z to the half is the same as z to the half. So you are going to have ln of y to the power half and z to the power half. And this is equal to ln of yz to the power half. Okay, and we are done with that question. So you guys want me to explain on D as well? Okay, let's try to explain. So we have 2 log 6x plus log 6 y squared minus log 6x plus 2. So same basis, what do? We multiply since we are adding. So we have 2 log 6 xy squared minus log 6 x plus 2. So at this point, the 2, we get the 2, and we raise we raise x y squared to the power 2. So it will now be log 6 x y squared in brackets to the power 2 minus log 6 x plus 2. So what does this tell you? You have to divide because there's a minus. So you're going to have log 6 x y squared over x plus 2. So if we expand the x y squared in brackets squared, we're going to get x squared y to the 4 and x plus over x plus 2. So we'll have log 6 open brackets x squared y to the power 4 over x plus 2. So that's what we have. So just go through them. These things are not hard, guys. So if you just know the principles, you actually realize I was just wasting my time on this tutorial sheet. I would have just left it to you to solve because it's easy, you know. So let's move on. You know, some of these concepts of mathematics, especially on logs, they just need to be on your fingertips, guys. Where if you just wake up, they ask you, what is log of this? You're able to tell. All right. Let's move to question 7. So question 7 is asking us use algebraic procedures. I've skipped question 6. I'm sure you've noticed I've skipped question 6 because I'm trying to avoid using a calculator because in this course you don't use a calculator. So I feel it was a typo for the lecturer to have put in this question. Yeah, because you need a calculator to solve those questions. So I'll straight away go to question 7. Because it will be more like I'm being hypocritical where I tell you not to use a calculator, but when I'm teaching you, I'm using a calculator. So it won't make sense. All right, so question 7. Use algebraic procedures to find the exact solutions or solutions of the equation. Use algebraic procedures to find the exact solution or solutions of the equations. So I'm going to solve some of the equations. So the A part says log open brackets log x is equal to 1. So log open brackets log x is equal to 1. So if you check this, consider this log x as a one thing. Because of the log that is there and the 1, so this is to the base 10. So you maintain what was your base, and then you make the 1 the power, then you make this log x, which is the argument. Let me just circle it. So you make this guy. This is your argument. Then consider that it has the base 10. So you will maintain the base, which will come now, let me just change the color so that we can see the difference. So this guy will now come here, and it will be raised to the power of this 1. So it will be 10 to the power 1. Then this argument is now your answer. So let me change the color again so that we are able to see. So this which was the argument is now the answer. So at that point, again, we proceed. It has the base 10. So what we do, we say we maintain the base, which is 10, and then raise to the power of what was your solution. So it will be 10 to the power 10. Then you have your x, which was the argument, will become the solution. So it will be x is equal to 10 to the power 10. So again, since you don't use a calculator, leave it there. Leave it as x is equal to 10 to the power 10, because those will be big numbers now. All right. I hope we understand. Let's move on. I'll go to C. Skip B. You can do B. We'll go to C. 9 to the power x is equal to 1 over 3 to the power 43 to the power 243. So we see that 9 to the power x is equal to, okay, someone is asking me to repeat. Is it necessary? Someone is asking me to repeat A, okay. So I said we consider this log x that is in brackets as a whole number. So it will be our argument log x. So this log is the base 10. Those people with bad manners, of unmuting yourselves after some time for no reason, can you stop that? You're disturbing. So, sir, the one who asked the question, so it will be log base 10, then we consider this as a constant number is equal to 1. So this becomes your solution, which comes here as your log x. Then you say the base, which was 10, will be raised to the power 1. And then from there, I'm sure you can solve. You can proceed from there. Okay, we go to C. 9 to the x is equal to 1 over 243. We realize that 1 over 243 is the same as 3 to the power 5. So we say 1 over 3 to the power 5, and 9 is the same as 3 to the power 2. So that 2 will multiply with the x, so we'll have 3 to the power 2x is equal to 1 over 3 to the power 5. Then 3 to the power 5, 1 over 3 to the power 5 is the same as 3 to the power negative 5. So this can further be simplified as we have the same bases, we cancel the bases and just say 2x is equal to negative 5. We divide by 2, we're going to get x is equal to negative 5 over 2. As simple as that. All right, we move to D. D is similar to A. Okay, I don't know why I even wasted my time solving it, because it's the same as A. But then ln of ln x is equal to 2. So you can even change this guy to natural log, because I like dealing with log, right? I don't like ln. So ln is the natural log of e. So natural log of ex is equal to 2. Then you can derive this and come to ln of x is equal to e to the power 2. Then you can have this ln is natural log of e, x is equal to e to the power 2. And then at this point, maintain the base, which is e, and raise it to the power e to the power 2. So it will be e to the power 2. So this x becomes your solution. So x is equal to e to the power e to the power 2. So if you want, you can actually expand this guy and just say x is equal to e, 2e to the power e. So x is equal to 2e to the power e. But if you want, you can leave it here, you still get marks. Okay, let's proceed. Especially if there's no question, I like proceeding because I don't like being left behind. Okay, so if we go to our third sheet, question 8. Question 8, the number of bacteria NT present in a culture at time t hours is given by NT is equal to 2,200, 2 to the power t. So the 2 is the only thing that is raised to the power t. So they're asking us to find if there is time t is equal to 0 and time t is equal to 3. So if we go to our solutions, NT is equal to 2,200, 2 to the power t. So when t is equal to 0, so where there is t, you just put 0. 2 to the power 0 is 1. Any number to the power 0 is 1. 1 times 2,200 is just 2,200. So we notice that at this point, the number of bacteria will be nothing but 2,200. That's the number of bacteria. And then at the time t is equal to 3, we just raise to the power 3 and say 2 to the power 3 is 8. 8 times 2,200, you get something like 17,600. As simple as that. So these are free marks, guys. Even if it came in a test, it's some free mark. I don't think there's a question there, but if there's a question, feel free to ask. Otherwise, we proceed to question 9. Esther, is that the question? Okay, let's proceed. How long will it take 1,000 to triple if it is invested at an annual interest rate of 5.5%, compounded continuously, round to the nearest year? So the formula is A is equal to P e to the power RT. So the R, the rate is 5.5%. Esther, if you don't have a question, mute your mic and switch off your camera. You're going to show us something else we don't want to see. And we'll end up hearing what we don't want to hear. Okay, let's proceed. So if you check the question, we've been given that it will take, how long will it take to get 1,000 to triple? So we want this 1,000 to triple. So we multiply the 1,000 by 3 for it to triple. And then it's raised to the power, RT is raised to the power RT, because RT is 5.5, which is the rate T. So it will be 1,000, then 1,000 E, 5.5 T. So we divide by 1,000, then we have to multiply by 3. So we have 3 is equal to E to the power 5.5 T. Then at this point, we can introduce ln. So if we introduce ln on both sides, you notice that the ln and the E will cancel. So you remain with ln 3. So you have ln 3 is equal to 5.5 T. Then you divide by 5.5 because what you want is the T. So your T is equal to ln 3 over 5.5. But then you can't proceed from there because you guys are not allowed to use a calculator. So you leave your answer just there. Okay, so and then we're done. We're done for today. Question 10, I'm not doing it because your lecturer told me not to do it as it was part of the assignment. Yes, Melik.
Why are you not converting the 5.5 to a percentage where you say 5.5 of 100?
Okay, what is 5.5 over 100, sir?
It's 0.05.
0.05. Then when we reach at this point where we are canceling the
Yes.
0.05, we still cancel.
Yes, we still have 0.05 over 0.05 way to find the value of t.
0.0555.
Okay, so just find it the way it is, sir. Unless if, let me take the question again. Yeah, unless you are told to change, but there, because they use this 5.5, which to get the 1,000. So just leave it like that. Just use it like that.
But sir, it's saying 5.5%, meaning you have to convert it to a percentage, not so.
It's not always, but at times, yeah, but it's not always.
So in this case, you don't have to convert anything, just have to use the same 5.5.
Just have to use it the same.
All right.
Sure. Any other question?